I don't know how I did it, guys, but I got a sample of Ozempic. Oh, semaglutide, the most popular diabetes drug on the market. We got the diluted intact Ozempic on our acidic big peptide method on the Zevo QTOF instrument. Looking at it intact, see if it's got any proteoforms or impurities. Opening up the 30-minute method, and you can see it's just one enormous super sharp peak, most likely at the exact mass charge state series of Ozempic. Let's calculate that out. A little history on Ozempic. It is a GLP-1 modifier, and this is the first of its kind. Really great drug for diabetes and anti-obesity, and just the best is yet to come for these peptide therapeutics. What it is, we got ChemSpider, and we got Drug Bank, and we got PubChem. You can see it's hard to see kind of exactly what this thing is. It's a large peptide with this long alkene fatty acid coming off the middle of a lysine. On PubChem, they also kind of show it in a skeleton fashion that's not that helpful. Websites seem to agree on this molecular formula right here. 187 carbons, 290 hydrogens. This one's saying 291 hydrogens, 45 nitrogens, and 59 oxygens. So pretty much the same. Looks like I'm going to go with the 291 hydrogens. Alright, so here's the charge state series from the real raw data, and what we can do is we can put an isotope model with the formula for Ozempic directly on top of it, and it should be show a charge state series here. We can create a charge state series on it. Let's hit boom right there. And so if we zoom in, we can see looks like we are pretty spot on for Ozempic there. Nice iso pattern, nice spacing. It seems completely correct. You can see we're seeing multiple charge states, all which match. Multiple charge states all match. Looks really good. This is a very clean peptide therapeutic product here. Now, if we start looking at, let's say, this peak right here, this peak is probably a dimer, potentially mass spec induced. Does not show up in the ISO model because it is not the right size. Other interesting things that don't match the model are these small proteoforms that are in front of the peak. If we right-click and drag across these little guys, we can see where they elute. The third peak actually elutes, and you can see there are two minor forms that separate chromatographically. If we click on these, you can see that there is a shifted mass, so there is a small modified proteoform impurity in the Ozempic sample. Let's try to figure out what that is. We know the mass is supposed to be 4,114 Daltons there, and so what we can do is calculate this 4114 divided by, and we look at our spectrum, and that's that 1029 peak, so 1029, and so that's our fourth charge state right there. So if we then go from the center of this peak and measure to the center of the modified proteoform, you can see that it's 10.5 mass difference. So the math is 10.5 times 4 to give you the real mass shift spacing. So it's a 42 Dalton mass shift modification. Let's go figure out what that could be. Got the mass shift list. This is all the known proteoform mass shifts that I got on my mass shift list. And we go and look at 42. And that is either a trimethylation on a lysine, or an acetylation on the N-terminus, the epsilon amino of a lysine, or the O of a serine. My guess, based on the structure of this, is a O-serine acetylation. That wraps up our Ozempic analysis, which shows a really sharp, clean product that matches the exact mass of Ozempic. However, we do have two small proteoforms, which are most likely acetylations on, my guess is a serine based on the structure, but could be also on lysines. I don't think that probably affects the product at all. Very well-made synthetic drug.